Good morning, students. In the today's session, we will learn about IPv6. In the last session, we have already completed with IPv4. This IPv4 and IPv6 are the two internet addressing techniques. Okay. Now we'll see about the IPv6. IP means what? Internet protocol. Okay. Here, like whenever if you learn with this IPv4, there we have learned about the wait. Yeah. Here previously the first addressing technique we have is the IPv4. Okay, Internet Protocol version 4. This produces for 4 billion addresses. But the developers that they are think the addresses are enough. But they are wrong because in the next generation the IP addresses the next generation IP address is the IPv6 because the main difference between these IPv4 and IPv6 is the address size of the IP address. Okay, in IPv4, it is going to take only 32-bit address. But whenever if you go for this IPv6, it will go with the 128-bit hexadecimal address. Okay, this is very important. And in the next here, like whenever if you're working with this IPv4 and IPv6, it is going to provide you the transition strategies that convert the IPv4 into IPv6. Okay, the main three strategies which we have to learn about this IPv4 and IPv6 are here. Like whenever the three strategies what we have, one is a dual stacking, another one is a tunneling, and the another one is a network address translation. What is mean by this dual stacking? It allows us to have both the versions on the same device. Okay. Here, like whenever you are working with the dual stacking, it is going to allow you both the versions of IPv6 and IPv4 on the same system. Okay. And whenever if you are working with the tunneling, this tunneling is also the another strategy which we are going to follow about this IPv4 and 6. In this approach, all the users have IPv6 communicates with the IPv4. Okay. Because here the network can able to reach the IPv4 network can able to reach with the IPv6 also. This is also one of the good strategy. And the network address translation. In this translation allows the communication between the host having the different version of IP address. Okay, these are all very important. The three different strategies are dual stacking, tunneling, as well as the network address translation. Okay. Now, here, whenever you are working with this IPv6, then in IPv6, we have the hexadecimal address. Whenever if you learn about this IPv4, there we have only octet. Octet means we have 0 to 7. Whenever if you go for the hexadecimal means we have 0 to 9 as well as A, B, C, D, E. Okay. And here, like whenever if you have this octet, the address format of IPv4 is only 4 octets we have. Okay. Like it means we have, for example, if we have 192.168.2.33 and we are going to convert this into the binary conversion. But whenever if we have, that means this how we can convert, we are going to convert into a normal binary. Okay. By taking the 8 digit. But whenever if you go for the IPv6 means here we have the 16 octets. Okay. There the numbering starts from 0 to 9 as well as A, B, C, D, E, F. Okay. Next. Here this above diagram, it shows the address of both IPv4 and 6. I have already explained this one. Okay. Now, here we'll learn the exam point of view. The majorly they are going to ask you about the differences between IPv4 and IPv6. Okay. And in IPv4 here, we have, it is the address length for the IPv4 is only 32-bit address because this the starting days they think that only the 4 billion people can use at most, but that is not at all right. Okay. Now here, now to overcome that problem, they have done with the 128-bit address in IPv6. Okay. And the fields for the IPv4 is only 4 we have, and each and every field is separated with a dot. Whenever if we have this IPv6 means here we have it, this alphanumeric address, it consisting of 8 fields which are separated by a dot. Okay. And now the classes for the IPv4 are, here we have class AB to class E. Okay. Here we have only 5 different classes. But whenever if you are working with this IPv6, we do not have any classes. Okay. And the number of IP address for the IPv4 is, it has only limited of IP address. But here, whenever if you are working with this IPv6, we don't have any limit. Okay. And the virtual length subnet mask. Okay. Here, this IPv4 will support the VLSM. But when we go for this IPv6, it will not support the VLSM. Okay. And this is also going to helpful for the transmission of DHCP. But whenever if you are working with this IPv6, this supports manual DHCP as well as auto configuration and renumbering. And the address space for this IPv4 is only 4 billion unique address. But here we have, it is unlimited. Okay. And this in IPv4, it is an end-to-end connection. Integrity is unachievable. But whenever if you go for the IPv6, here we have end-to-end connection integrity is, it is achievable here. Okay. Yeah. In IPv4, the security features are, the security depends on the applications. Okay. Here, the IP address is not developed in keeping the security feature in mind. Whenever if you go for the IPv6, here it is developed for the security purpose. Okay. And when we are working with this IPv4, the IP address is represented in decimal. In IPv6, that it is represented in hexadecimal. Okay. And the fragmentation is done by sender and the forwarding routes. Here the fragmentation is done by thousanders only. Okay. Here, now here this fragmentation is done both at the sender as well as forwarding routers. But here we have only by the senders only. Okay. And the packet flow identification, it does not provide any mechanism for the packet flow identification. Whenever if you are working with this, here IPv6, it uses flow label field in the header for the packet flow identification. And the checksum field is available in IPv4. Checksum field is not available in IPv6. Here, this IPv4 is broadcasting. And on the other hand, this IPv6 is multicasting, which provides the efficient network operations. Okay. And encryption authentication means here it does not provide any encryption or authentication. But here, whenever if you go for this IPv6, it provides encryption as well as the authentication. Okay, and the number of octets are 4 for this IPv4, and it consisting of 8 fields and each field consisting of 2 octets. Okay, therefore the total number of octets in the IPv6 is 16. Okay, now we have completed with the IPv4 as well as the different IPv4 in the last session and IPv6 in this session as well as the difference. Okay, this IPv4 and IPv6, these are the two addressing techniques which will be used for the transmission of data between the sender and the receiver. Okay, thank you. All the best.